Hi. In this video, we're going to look at how to think about situations involving Newton's third law. So let's look at this example together. While bowling with her friends, Jessica sits and waits her turn. She has a mass of 39.5 kilograms. I'm going to illustrate this situation because it's always helpful in physics to have a picture. So here's my picture. It's a spectacular picture, as you are beginning to see here. So we have a person sitting on a chair, and just as a reminder, that person is being pulled down to the earth because of gravity. Um, but there's also an upward force acting on the person from the chair. So we have two forces acting here. What is the weight of Jessica's 39.5 kilogram body? So we got a bunch of questions. Let's start with this first one. Now, it's sometimes easy to forget that we can calculate an object's weight in physics by taking the mass of the object and multiply by the acceleration due to gravity on Earth. Remember, the acceleration due to gravity on Earth is 9.81 meters per second squared. So that's what g is on Earth. So, real quick, we'll just do that math. 39.5 kilograms is the mass times negative 9.81 meters per second squared. And we multiply those two quantities together using our calculator. And I've got my calculator here. 39.5 times 9.81. It is negative, so we'll round that to have three significant figures. That's going to be negative 3, I already forgot, 387. It's negative in this case because it's downwards, and so the weight is directed down. When you're answering questions like this, you don't necessarily have to include the negative sign. In physics, remember, negative just means the direction. So if you're not asked for a direction, then you might go without the negative sign there. All right, question 2, it says, with what amount of force does Jessica push down on the chair? Well, she has a weight of 387 newtons, and what other force would she be using to push down on the chair? So I think that once we found her weight, we've found how much force that she's pushing down on the chair with. That's 387 newtons, and that is downwards. And then the third question says, with what amount of force does the chair push up on Jessica's body? The chair is going to be balancing the amount of force pushing down. And this is what Newton's third law has always said. The amount of force that you push with, there's an equal and opposite amount of force pushing back. And so that's going to be the same answer, 387 newtons, this time up on Jessica's body. All right, question 4 is where something different happens. Jessica's friend Paul hands her an 8-kilogram bowling ball, which Jessica places on her lap while she continues waiting. What amount of force does Jessica's lap push up on the bowling ball? So we are introducing a new object now. And so I'll put that object right here. All right, and that object is being pulled down towards the ground, and then Jessica's lap is pushing up on the ball. So we need to figure out how much force is her lap pushing up on the ball with right here. That's just going to be equal to the weight of the ball. So we need to do the weight equation again. But this time we're looking at the weight of the ball. So the mass of the ball is 8 kilograms. And again, we're multiplying by negative 9.81 meters per second squared for the acceleration due to gravity on Earth. Take our calculator and we do 8 times 9.81 and we get 78.5. Okay. 78.5 newtons downward. So that's the amount of force that the ball is pushing down on Jessica's lap with. So we found that force, 785 newtons. Or sorry, 78.5 newtons. But the question asks, what amount of force does Jessica's lap push up on the bowling ball? And it's just going to be equal to that amount of force that we're pushing down with. So her lap is going to provide an upwards force of 78.5 newtons as well. So that is our answer here. It's just equal to the weight of the bowling ball. All right, now the last question is where we kind of put everything together. It says, with what amount of force does the chair now exert upon Jessica's body? So now the chair is pushing back on two objects. It's pushing back on Jessica and the ball. So excuse the bad picture here. But the chair has two things to support now. So there's, a combined force of Jessica and the ball. So we need to figure out how much combined force is that. It's just going to be the weight of Jessica, which is 387 newtons, plus the weight of the bowling ball, which is 78.5 newtons. So we add those two together. 387 plus 78.5. We get 465.5. We need to get rid of the decimal place though. So we're going to say 466 newtons for our answer. So that's all I've got for you in this video. Remember, confusion is the sweat of learning.